Hello students, today is lesson 5.6 on disjunctions. So I wrote two little sentences on what the difference between conjunctions and disjunctions are. So a conjunction, which we did last lesson, uses the word and. That is a big part of the difference between the two. And it's where the graphs intersect. Okay, the next one, the one we're doing today, is a disjunction, and that uses the word or. And it includes anywhere that both of the graphs are. So we're going to talk about that a little bit today. Okay, let's go ahead and start with an example. So example 1 is going to be x is less than 4 or x is less than or equal to 2. So in yesterday's assignment, I may have left out that word and some of the times, and I just wrote the two inequalities. But the and was important because it said that the answer needed to work with both equations. Both inequalities. So today we're saying or. So the answer can work with either one of those. It doesn't have to work with both of them like with conjunctions. So when we're going to solve it the same way. We're going to do a little graph. Okay, this is, I want to go to at least 5. I'll just go ahead and put 6 there to make it look pretty. Okay, so now when I'm putting it on the graph, I'm going to have the first one is x is less than 4, so it would look like this. Now remember, I'm putting these above the graph just before I do the whole graph. Okay, this is not how you usually do graphs. This is just to help me see where everything is. Okay, and then the next one is here. X is less than or equal to 2. So yesterday we would do the part where they intersected. So we would have done this part. But today we're not going to do that. Okay, today we're going to do where they both are. So this time it's all of that. Okay, so in other words, it's the whole thing. So my answer would be here and to the left. I hope you can see that. I'm going to make it a little bit darker. Okay, so now I would write the equation or inequality just for that part of the graph that I shaded. So that would be x is less than 4. And that's my answer. Okay, x is less than 4. So where yesterday we were doing where everywhere that both of them were, so both the lines had to be there, today we are not. We're doing either or. So it can work with whatever number you get. So let's say my problem is it's some kind of a word problem or a real world problem where in maybe some engineering or something, it's saying, well, you could have anything that's x is less than 4 or x is less than or equal to 2. So then I would pick a number, let's say 5, and I would say, well, does 5 work in that problem? No, it doesn't because it's not less than 4. Okay, but 3 would work, right? 3 is inside of one or the other. It's in this graph, not this graph, but that's okay because it only has to be in one of them. Okay, let's move on to another example. Example 2. Okay, let me get the inequality here. Okay, example 2 is x is less than -4 or x is greater than -1. So let's talk about that and or. So if your mom told you you need to do the dishes and take out the trash, okay, are you only going to do one of those things? No, you're going to take out both the dishes and the trash. But what if your mom said, okay, you have a choice. You can either do the dishes or you can take out the trash. Okay, that way you're only going to pick one, right? You're going to take out the trash or you're going to do the dishes. But you don't have to do both of them. So that's the same situation with conjunctions and disjunctions. You're using Conjunctions are where you have to do both. You're using the word and disjunctions are where you pick one or the other. You don't have to do both. Okay, so let's solve this next one. We have negatives this time, so I'm going to work backwards when I'm doing my graph. Okay, so this time the first one says I am going to do x is less than, oops, I don't want it on the graph. X is less than -4 or x is greater than -1. So this time our graph does not intersect. And when we were doing conjunctions, we would say that there was no solution to this because they did not intersect. But because now these do not have to intersect, we can pick one or the other. That means our answer is going to be the same as our problem is. It is both x is less than -4 and I'm not using the word and, or it is x is greater than -1. And that's my answer. Because my answer, if I'm picking a number, it can be on either one of those graphs. Okay, example 3 is 3x plus 4 is less than or equal to 16, or -5x is greater than 20. So now I've got one with inequalities where I have to solve them. That's okay. It's the same thing we've been doing. They kind of just want to keep you up to practice on solving these things. So I'm going to subtract 4 from both sides. And then I'm going to divide by 3. So I get x is less than or equal to 4. And that's my answer on that one. Maybe I shouldn't have boxed it. Oops. Let's see. Okay, now let's do the other side. On the other side, I'm going to divide by -5. And when I divide by -5, I need to flip my sign, right? So I get x is less than or equal to -4. Okay, so now I have this one or this one. Okay, so let's draw a number line. And I need to go from 4 to -4. That's a lot of numbers in there. So I'm going to have 0 in the middle. I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'll go ahead and go to 6. So this is -4, -5, -6. And then this is 4, 5, 6. You can fill in all the other numbers, but because it's just notes, I don't necessarily need all the numbers. Okay, now let's go in there and do some work. So this is x is less than 4. That's right here. Okay, and the other one is x is less, I'm sorry, that was less than or equal to. And then the next one is less than -4. Okay, so since I have both of those and the answer could be either of them, remember I'm going to do where both of them are. So that means I'm going to have this one. Hold on, I'm going to use a different color so you can see it better. I'm going to have this one as my only one because it also includes this one right here. Okay, so if I have that as my answer, then my answer would be x is less than 4, or less than or equal to 4. And that's my answer. Right? Okay. And our last problem, example 4, is once again one where we are going to have to solve it. We have 3x is minus 6 is less than or equal to 12, or 5x is greater than -25. Okay, so let's go ahead and solve both of these. I'm going to add 6 here. That gives me 3x is less than or equal to 18. Then I'm going to divide by 3. So x is less than or equal to 6 on that side. Okay, and then on the other side, I'm going to divide by 5. And so x is greater than negative 5. So I have this one or this one. Okay, so now let's go ahead and go to a graph. Okay, this one is very different than the other ones. Okay, for time's sake, I'm going to go ahead and just do like this. Okay, you can fill in the numbers if you want to. Okay, so the first one is x is less than or equal to 6. So it's like this. And then the other one is x is greater than or equal to negative 5. So it's like this. Okay, so if I take where everything is on this graph, okay, notice that I would have on my regular graph, it would just go the whole way. There's no dots because the dots are in the middle here, and like it would be like if I did this, and we don't make graphs that look like that, right? So there's no dots. The yellow line goes across the whole number line. So what would that mean for my answer? It means both of these are working, but I'm not going to write both of them as my answer because my line is covering my entire number line. That means my answer is going to be any number. So x equals any real number, or you could just put any number. The reason we use the word real is because later in Algebra 2, you learn about imaginary numbers. But we're not going to talk about imaginary numbers because that's for later in your math career. But that's why we use the word real, because there are imaginary numbers. So that's my answer, is that it can be any number. If I pick any number, let's pick 100. That would work in both of these situations, right? And x is less than or equal to 6. If I said x is 100, that equation works. X is less than or... I'm sorry, I meant to say... oh, no, it does not work in that one, but it does work in the other one where 100 is greater than or equal to negative 5. And it only has to work in one of them. So it works in that one. Remember, it's like doing the dishes or taking out the trash. It has to work in one of them, not both of them. So it works in that one. So 100 would work. And if I picked a different number, if I picked something like negative 1,000, that one would work in this one. So that one works also. So any number works in these inequalities. So that's the end. And hopefully you can get the homework done well on this one. Just remember, these are different than conjunctions. These have an or in them. Okay, that's all.